curtains are about to fall. We're gonna open your eyes so you can see who you're gonna call if you wanna be free. Globebusters! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! Globebusters! Globebusters! Globebusters!
And welcome everybody to GLOBEBUSTERS.
We accept the reality of the world with which we're presented. It's as simple as that.
And welcome everybody to GLOBEBUSTERS Season 9, episode number 27. Believe it or not, that is a lot. It is time for Astronomy Night, believe it or not, with a 14-inch telescope. So exciting that we'll be able to do that. We're going to have, I believe, somebody on the line here shortly who is currently hooked up to his 14-inch telescope, and we'll be making some observations. So that sounds like fun, doesn't it? And we've got some guests with us. We've also got Iru Landucci from the land over and across and down under and upside down. Iru, ¿cómo estás, mi amigo?
Very well, man. Very well. I just dream about the day where we can talk in Spanish and a super AI with a Skynet connected to your ass translate in real time.
Any day now. It's gonna be awesome.
Yeah, any day, man. Take a look of your ass, because any day it's gonna be a cable appears suddenly,
It's gonna
and
be
it's
amazing.
gonna start speaking Spanish. Yeah,
I'm still wondering when we're going to be able to talk without a delay. You know, when they talk to the ISS,
to the ISS.
Yeah, 250 miles is a long way. So
Yeah.
You got to have
multiplexors.
you got to have
things
multiplexers,
like that,
multiplexers. Yeah, exactly. So soon we'll be able to do that. We got Good Times for All. Zach Rizabala. Zach, how are you, my friend?
Hey, Jeran, doing good. Yeah, I love Achilles' videos on the sky. It's one of those things that, you know, you look at it with your eyes, it looks like one thing. You look at it through a 14-inch scope, and there is some really amazing, beautiful stuff going on up there. There really is.
Yeah, he's got some great footage, and I believe that he's got something that he thinks is a huge debunk of the model that they tell us, because and I've seen the videos of it. Basically, if he zooms in on the moon when there's a star behind it, he can get both in focus, which he thinks is impossible if the distances are what we're told. But he's not here yet. All right, let me show you guys real quick something. We do have tickets on sale today for.
Right.
Let's go here. What happened?
All right. Hello.
Hey, you're there.
Yeah, finally.
Okay, we got
Hello
you.
from Greece.
Hello. How's Greece doing? You guys
Hello,
okay?
my friend.
How are you guys?
We're doing excellent.
Very good. Very good.
So, what do you like to go
lovely
by the
show.
way? Achilles?
Previous show. I just wanted to say that the previous show was excellent. It was a great introduction to those that just don't want to believe in the truth, and I loved it.
Good
job.
And
The timeline.
you like to go by Achilles?
Yeah.
Okay. And you're going to hook up your telescope tonight? Is that the plan?
Yep. Yeah, I'm right outside at the balcony, hot coffee in hand.
Okay, do you need me to pull up StreamYard and have you go on there, or you can do it through Skype?
I don't know how to share my screen on Skype. Let me check it out. So desktop, start sharing, share computer sound. We will not be needing that.
Okay.
So, okay, I think it should be okay. If you're getting my screen, I see a red block
Yes.
all over it.
Yep. Let me show one thing and then we'll go right to you. So go ahead and get that ready.
Okay.
So we've got the True Earth Mount Meru 2 Virtual Summit coming in 2 weeks. That's going to be the December 8th and 9th. Tickets are on sale now. You can go to trueearther.com and just either register for free if you want. You can hit buy now. December 8th and 9th. We've got a good lineup for you. And we have started posting. Oops, let me see if I have this one here. I don't have it on me. Nope. Let's see here. Yeah. So just so you know the schedule of what's going to be happening on those 2 days. We've got myself going to be opening up, and then we've got. Oops, let me go here. Shoot, there. So we got that one. There we go. Now we've got myself, then Justin Harvey. You guys know him from his vaccine work, and also obviously he's the one who spoke to City Council about the NASA lies. He's going to be there. Alan from Space Audits is going to be presenting Friday night. Stephen Dragon presenting Friday night, and then Amanda Vollmer and Dr. Amanda Vollmer. And then we've got Avocado Wolf, David, doing the last presentation on Friday. We've got then the panel. It's going to be Stephen Dragon, David Weiss, David Avocado Wolf, Justin Harvey, myself, and Austin will all be on the panel Friday night. Then Saturday we've got, by the way, Friday Foundering will be doing the opening music. We've got Deepak doing the opening music on Saturday. We've got Dr. Andrew Kaufman presenting first, Dr. Kelly Brogan presenting second, Iru Landucci presenting third, Stellium 7 will be presenting fourth. We've got then lunch, then Deepak will be back to do a little half-hour music session. Then we got Mike Winter, if you don't know who he is, he's from Alphabetic, awesome. Then we've got Jay Tolan Media, so Jay will be presenting, and then we've got Isabel Amiga from 4 to 5, then Austin Witsit from 5 to 6, and then we got comedy with Ian Cunningham to close us out. So it's going to be a fun session. Let me get this over here for you.
And what Jay Tolan is going to present, the measurement of the universe.
Yes.
That's the next step, man, because
through infrared.
It's going to be amazing. That
it's going to be amazing. We're looking forward to it. We're really happy that he was over in Vegas. If people don't know, he was at the Flatoberfest, so we got to talk to him a lot. Yeah, so he's excited to come on and present. And then if you just click buy your ticket today from the site, it'll take you to the store. And there is some good items. Again, general admission for just this event. Then there's general admission for the year, which gives you this event.
What a nice logo, man.
Yeah, it's a great logo. I don't know who made it. Iru, by the way, does our artwork, if you didn't know that. So we got general admission. You get the next 3 events. So it'd be Mount Meru plus Equinox plus Solstice with a little bit of a discount. You can also buy all the past summits if you want, but any one of these purchases actually gets you all the past summits anyway. So if you buy a $50 ticket, you get all the past summits that we've done. But if you didn't want this one for any reason, you just want the past ones, you could pay $20. Then we got VIP. The cool thing about VIP this year, we're going to have some raffles with a little bit bigger prizes for VIPs. And then we're going to be doing an after show or an after party, as we call it, with Austin and I. And that usually goes late into the night on Saturday. And we just hang out with all the VIPs. And we'll give everybody a chance to speak and do whatever they want, ask us questions, or just whatever you want to do. Then we've got the annual, which is, again, the next 3. And then down here, if you can't really see this. For $23 right now, we have Conspiracy Music Guru, who's offering his entire album discography. Is that what it's called? I guess all 5 albums. So you've got let's see, we got the Black Sheep album, we've got the Flat Earth Man album, we've got the True Safa. I don't know how you say that. Safa Giglio? No. It's
yeah, and that one alone is worth that price.
Yeah, it's awesome. Then he's got the Unplug album, and then the what does that one say? Live and Unplugged album. So all those you're just going to get a link that goes to a Dropbox file that has all the songs in there, all in MP3. It also includes the album teaser videos and all the thumbnails for all the songs and everything. So that's a great package for only $23. Get that today if you want to support Conspiracy Music Guru, and that's also in the store. If you have any issues or anything, you can go to this contact button, fill out this form. It makes it really easy for us to address those concerns. If you have questions about the terms, you won't really have much. Instructions, if you need help figuring out, what am I? And this just kind of lays it out there. If you're already a member at trueearther.com, here's your steps. If you're not, here's your steps. And that's basically it. There's an FAQ with not much important there. How do I get support? How does it work once I purchase my ticket? How do I join the Zoom? Where can I find my virtual gift bag? And this one's asking, where does my payment go and do the speakers receive compensation? So if people don't know, the way that Austin and I have ran this from day one and continue to do the identical thing is we like to pay the presenters for their work, so coming on. So about half of the proceeds go to the person that you pick when you sign up. So for instance, if we pick this item here, get in there, and we are going to buy one, we hit continue. We got an option of tons of crypto payments, lots of different types. You can see up here, Bitcoin, Ether, Shiba, Wrapped Ether, DAI, Bitcoin Cash, Tron, Binance Coin, Polygon, Solana, Monero, you name it. So Monero, if you want to do it privately, you can do that. Let's just say we pick one of those. Let's say we're going to do Monero. Okay, so you can pick Monero. We're going to click continue. And then you'll notice here it wants my email, but then right here is the mandatory. Please use the drop-down to select the name of the presenter that you wish to support with your ticket, and or select split by everyone to have it split 15 ways. So here's your list of presenters. So if you want to give Iru your love, just click Iru, turn on the I agree to the terms, and click continue, and it will go for, well, you have to put in an email address. But that's basically how easy it is to select who will get the half of your payment. And if you want to split by everyone, just go like that. And then what we do is just take that particular purchase, take the amount that we would usually pay the person, and just divide it by 15. So it comes out to about $1.33 each if you're buying the $50 ticket. So hopefully you guys are getting ready for that. Should be fun. We've enjoyed doing the last few and looking forward to this one. Jay Tolan's new, Justin Harvey's new, Alan from Space Audits is new, Kelly Brogan's never been here, Dr. Andrew Kaufman's never been here. So we're looking forward to another fantastic event, and that is Mount Meru 2 coming in 2 weeks from yesterday. All right, let's get back to see if his telescope is on yet. Let me put
That's an awesome lineup there, man.
Yeah, so far
Well
we got
done.
really lucky. We expected somebody else for the comedy. Not that we didn't want Ian. Ian's going to be great. But it fell through, and I'm not going to call the person who pushed it yet. I'm going to give him one more event. But I think it had something to do with the topic of the... Because at first it was like, oh, I'll do it. And then it was his manager wrote me and said, we're going to pass. I'm like, on what? The event. I said, no, he already agreed. No, we're going to pass. Okay. All righty then.
Wow.
What are you going to do? What are you going to do? Let's see here. Okay, go ahead, Al. Let's see. Oh, there we go. That's live right now?
Yep.
All right, let's bring this on. Let me share.
Here's our boring satellite.
Okay. Yeah.
And it's boring because when I bought this telescope, first off, this is not my telescope.
Okay.
This is the Guider scope, which is a very small telescope located on my telescope. But I think it's a good introduction to begin with this one. But I called the moon boring because when I bought the telescope, I was like, oh my God, I'm going to find everything on the moon. I'm going to find aliens. I'm going to find like crazy stuff. There's nothing up there. It's just is. It took me some years to find out.
So that's just the guide scope, you mean? That right what we're looking at now?
Yes.
Okay, gotcha.
And we will zoom in.
Okay.
So
we won't see aliens? We won't see any of them?
If you see any, let me know.
Okay.
Yeah, I have this telescope since I think 2010, 2012, somewhere there. I haven't seen one looking back at me yet.
Okay.
And
maybe we could find the Masonic flag that Buzz Aldrin took up there. If we look carefully.
Yeah, and they're telling you that no matter how big your telescope is, you can never see it.
No.
And I ask why.
Well, they say you need like a 30-foot telescope or something.
Yeah, well, mine is a 14-inch. Like we can fit 3 heads on it. So I should have be able to see what they left behind, at least, you know.
You would like
but anyway, so I'm gonna transfer the camera. Before I do, I want to get into my the main thing that I discovered with this telescope. And when I did, it really blew my mind. I wasn't ready at the time for the argument of the shape, so I couldn't understand. But before I even get to that, I want to tell the viewers that I'm not a member of the GLOBEBUSTERS, and I consider myself a GLOBEBUSTER, but I'm not a member of this channel. So I just want to start again, as I did last time, by telling people to support this channel because it has many expenses. People are going through a lot to give you the truth. And if you support it, you are helping the truth. So when there is, I said this again, when there is a war, you don't have to be at the front lines. You can buy the bullets. You can clean the guns. You can buy the food. Let the guys fight the front and risk whatever they are risking because their IPs are public for YouTube. They are at the front and you can buy them bullets. I want people to realize that from their home, from their leisure, They can support the war against lies, and those liars. So,
well, thank you.
Now, so I'm touching
switch?
the.
Oh, good.
I'm touching the knob, which alters the focus. So now we are intra-focusing, and we are perfect here. This is the perfect spot. But now I will continue, and we are going extra focal. So if I do it much more, it goes like this. If I go all the way in, and then it goes the other way. All right, I'm going to repeat this process for the eye to get used to it, because what we're about to see, it really messed up with my brain when I did it. So do you see how small the perfect focus window is? It is tiny. It's from here to here. And we are focusing on an object that is very close to us. The moon is supposedly very close to us. I will get to the distance that it has in a little bit, because that doesn't make sense either. But first, let's just think that we are right on the moon. So I get perfect focus, and here we are. So I'm going to tell my telescope now that I want to turn to an object which is 2,500 times further away from the distance of the Earth to the moon. And that object is Jupiter. So if anyone who is viewing considers Jupiter to be close to the moon, they are wrong. It's not very close to the moon. It's actually super far.
That's correct, though, 2,500 times? I'm gonna double check you on that one.
Yes. What you have to do is check the lunar distance and then find the Jupiter distance and divide the two. It's 2.5K times away. From 2.5 to 3 something, because the distance changes. So I'm telling the telescope to go there. And we are going to see this with the bigger scope as well. But for the eye to get acquainted, we're starting with the smaller telescope.
Yeah, what did you say? I have about 1,700 times, but still ridiculous. I didn't even think it was that much. So that's because I guess they're always different, right? The distance away from the Jupiter would be different all the time if it's on the other side of the sun or whatever. So I think that they show it as like 400 million. We would take that divided by 230,000, right?
Yeah, the difference is that they are giving us the distance to Jupiter in astronomical units, which is the distance we have to the sun.
To the sun. Okay, good point.
So an astronomical unit is not the same with the lunar distance. So if you look at the astronomical unit, you will see how many miles that is, and then you can divide with the lunar distance.
Okay, gotcha.
But it is
yeah, it looks like you're about right. It looks about that much.
2,413 times when it's at its closest, and it can go up to 3,300.
Yeah, I just did it again. I got 2,340 times. So yep, huge distance. Yep.
So now I'm gonna.
Are we supposed to see something? We don't see anything just yet.
You're not seeing it yet because I've had trouble. I had 2 days of very bad storms, so I had to get the telescope in. And when I took it out, I had a little bit of trouble with alignment. And I did align it, but my scope, my guide scope, I don't use it. So it's not, the guide scope is not aligned to the telescope. So don't worry about it. I'll just take a minute and find Jupiter.
I'm going to announce something else too I want to mention. So by the way, we do have a hard stop today at like 2:15. I'm going to start closing it down so that by 2:30 we are done. And that's because we've got this going on my channel at 3 o'clock. So on the Jeranism channel at 3 p.m. Pacific, 6 Eastern, is a debate. These guys were not going to debate, then they were, then they went back and forth. And so finally because the time was hard too, because Craig's in the UK, so it was the best time they could come up with that both worked for both of them. And I knew it was impacting the show a little bit, but I said, okay, if we do it at 3, then I can be done with GLOBEBUSTERS at 2:30. So 2:30 will be a hard stop. I'll head over there and then moderate the debate. So it should be interesting. They are kind of on their own. They didn't really like my format, which I get. Some people don't. They just want a moderator to moderate, and they're just going to chat. So that's basically what's coming up. But it's something that Caleb said he would never do. He would never debate this guy. So it should be a fun. Wow, look at that. Okay, we'll go back over here. So anyway, that is starting right after this show on my channel. Let's get back over here because we're now seeing the moons.
So we are now focused on Jupiter. What I haven't done is change the exposure. I put it on max so I can find it easier. But I want you to notice that we can see the moons. Like this is the correct for Jupiter. I can zoom in. Oh my God, not zoom out, zoom in. But we're going to see it much, much closer. Why doesn't this go away? Okay. We're going to see it much, much closer. What I wanted to focus for right now for this scope is that the moons are in focus. So there is a tiny, tiny object which is 2,500 times further away than the moon. And when we focused on the moon, we turn to Jupiter and we can see the moons. So let me show you how we go out of focus and in focus. This would be out of focus. You don't see the moons. This is close to focus. Let me put it in the center. Sorry.
No problem.
Sorry for that. Yeah. Speed 2. Okay, speed 2 takes a long time. Speed 5. Let me bring this here. So this is out of focus. And this is in focus. So we turned from the moon to Jupiter, and this is the other focus, the extra focal. We turned from the moon to Jupiter, and we were already focused to the moons. Not just the planet, but the tiny things that you can see how small they are compared to the moon. So now if I turn to the moon, our focus is going to be perfect. So when I was reading the manual of this telescope in 2010 that I got it, it was saying that if you're having a hard time focusing on a planet, turn to a star, focus on the star, and then turn to the planet, and the focus will be perfect. That didn't make sense. How can that be? So before we move to the bigger telescope, I have one picture. Well, I don't think the picture matters that much, but I will show it anyway. People, what did I do with it? Why isn't it here? Okay, it should be right here.
Hey, Zach, can you put a link to his channel on the in the chat for me?
Yeah, absolutely.
Thank you, brother. I promise a lot of weirdness to anyone that will join my channel.
They already expect that from us. That's right.
Yeah, Jeran knows. I'm very hard to make sense. So
wait, this is not with the 14-inch telescope, or this is?
No, this is not. I will center Jupiter.
Okay.
And change the telescope, and the difference is insane. So in this picture right here, we see lenses and focal lengths, and this shows us up to 600 millimeters focal length, which means that instead of seeing outside this triangle, the purple triangle, you move closer and closer and closer, zooming in on the far distance. And on this picture, we got a 600 millimeter. Our telescope is 3,556 millimeter. and we multiply it with a factor of 2.5, taking it to 8,890 millimeters.
Wow. It's over 4 times the, what would that be, the P900? Isn't that a 2,000 millimeter? Or is that
I don't know. I don't have the I don't have that camera. I've heard a lot about it, and it has disproven the curvature in so many channels.
Yours has 4 times the magnification power. That's amazing.
But it has a problem, which is that it also carries around 80 times the size and the weight. So it is a
around your neck,
160 pound telescope. 160 pounds. Yeah. So I cannot carry it to a beach.
P900. The P900 is too heavy to be carrying around for me.
It is pretty heavy, though.
And I haven't been blessed with an area that I can look into the horizon. I have a mountain, I have the house on the back, and I have trees all around. So burn the trees now, because there was a huge forest fire.
What's the light in the upper left here?
What is what?
I see a light in the upper left. Is that a moon?
Yes.
Red one? Looks red.
Yes, because if you go to Stellarium, you are going to see the names of the stars. Does anyone have Stellarium in their computer?
Yeah, I can do it. I can bring it up. Tell me your location, or just like the city name or something.
It doesn't matter. It doesn't matter.
Okay.
Just go where.
Yes,
it does. It does. Athens, because they will change. No, let me do it, brother. Let me do it, because we'll get it straight. So yeah, this one is giving a red. I think it's Ganymede.
Okay.
But the funny thing is that there is one which is way outside, and I saw it as I was looking with a telescope. It's like it's a different planet on its own.
Well, they say there's how many? Like 75, don't they?
Yes, but 4 are the Galilean moons.
Right.
Io, Europa, Callisto, and Ganymede.
Right.
So I'm not sure. The screen is not coming through because it's a program. I should turn it to window mode. But anyway, let me tell you which one that is. It's Callisto that is out there.
Okay.
Then those that are close to Jupiter, going from left to right, is Europa, Io, and Ganymede.
Okay.
So I don't know what the fifth is that is way out there. But anyway, I'm gonna center this now and go change our camera. And we're gonna see this refocusing problem with higher magnification, not highest, higher. So, you can unshare my screen for a second.
Yep, put this over here.
I will turn this.
So people could see that this is kind of the view from Athens, although it's kind of, turn yourself a little bit orientation-wise. But yeah, Callisto. And I don't know where all the other ones are. I guess we'd have to. Do they show them? Probably not.
You have to add also GMT +2 is the time that we have here.
Yeah, so it should be what? 4:26.
4:26.
What time is it for you?
It is
8:26.
10:38.
Oh, so you're
8.
Gotcha.
And that doesn't matter
so
much, but I just did a synchronization with the internet time, so your clock is off 2 minutes.
Okay.
No problem. Just saying.
I always get confused on the time on this, but I'm thinking because it's current, so if I just go to current time, it should be fine. 12:38, yeah, that's good. And then we're in Athens. Okay, good. What happened to look what I was looking at. So the moon is like straight above Jupiter right now for you? Or about there?
Yeah.
Okay.
Yeah. Very close enough so for us to do this comparison. I have a video on my channel which is called Refocus. It's in 2019, so you have to scroll a little bit further down to find it, which is where I first observed this problem, or not observed, recorded it. I was waiting for an alignment for those two to come together. And we are going to talk about the occultation in a little bit, which proves this point. And I want to call out the astronomers on the Earth I call them narcissists with telescopes because they only use their telescope in order to take a picture of something, dedicate their lives on doing that, and just add their name to the picture. That's all what they do with telescopes. So if you just care to make your name known and don't do any science, because the problem that I observed, the refocusing issue.
Tell me when you're ready to put your back on the screen too. Whenever you're ready.
There are you can go.
Okay.
We're fine.
Okay.
So what we are seeing. This is when I'm walking. What we're seeing right now is a moon. And it's out of focus. We're gonna focus. It's gonna be a little bit tough to find. I'm gonna turn the focus knob.
Now, can you explain how the atmosphere will affect what you're seeing sometimes?
Yes, and this is where we're gonna go next, because we also have Saturn, and he's moving close to the end of the horizon, and we're gonna observe a little problem that has. So this is a moon. I'm not sure which one right now, but I'm gonna take us to the planet. There's our little Jupiter. So that's the difference of the telescope with the gyroscope. Sorry for that. I'm moving around, and do you see how much it gets affected by walking around it?
Oh yeah.
Hello, Mr. Jupiter.
You might have to eat your words here, FE Nation. If you think your P900 gets that image of Jupiter, send it to me. I guarantee you cannot.
Yeah, it doesn't. Not that one.
This is one of the clearest views I've ever gotten of Jupiter. And we could actually exploit the moment to take a picture of it, because we are about to move double that distance. But let's try to take a picture of it before we go there. Sorry for moving around all the time, but cables, the handheld, all this. So let me center it. Oh, let me change the speed. Now speed needs to be 1. And now this is the center. This is where we want it. My monitor is moving. Why? Why is my monitor moving like that? Give me a second, guys. Okay. So a little bit more movement, because I need to refocus it. And now you're gonna also see how thin the window is on focusing. So please stop moving. Okay. So we're moving out. Okay. We're not focused. And now we're moving in. The reason that it's moving has to do with these specific telescopes, which are called Schmidt Cassegrain.
Right.
So every time you turn the focus knob, that the image shifts, and then you compensate by bringing it back into view, and you have to both focus and move the object. Can get a little bit tricky. And to find the perfect focus when that's happening can be tricky. So I think this is the perfect focus.
That's the best I've ever seen from a telescope myself.
Should I leave it here, or should I try once more? I'll try once more. That's a problem. You never know if you can actually improve it a little bit.
Now, if you were to take a bunch of stacked images like they do, and then
that's what we're about to do.
Okay, and then then it comes out super clear looking, right?
Yes. Yes.
And the feeling of the fade out to black is also due to the vignetting effect of the lens.
I heard the second part of the statement. I didn't catch the first. Which effect? The fading out?
The vignetting effect, because when we take a look like this, we can see like a little fade away, fade to black into the borders, giving the feeling of a perfect spherical thing. Could be, no, it doesn't matter. It's not related with the shape of the Earth. But a lot of people get confused sometimes because we cannot say 100% this is a sphere. And when you take a look to the visuals, it gives you this sensation because when the light is focused in the center of the mirror in the telescope, give this vignetting is the technical name,
okay, gotcha.
which is this fade away to black from the center to the borders. So I don't know if you have something.
It could be, but I can tell you one thing, that the first thing I wanted to see was to see if they are spinning. And I've made animations that you can find, Jeran, and you can bring them up in my channel under a playlist called Heavens Declare His Glory, because I used to have that playlist titled Solar Neighborhood. But at some point, I realized some things about the name Solar, some Apollo worship, and I changed the name of the playlist. But in there are some animations that I've been trying to get to see if the object spins, and it does. There is no doubt about it. It looks like it is a ball, and the things, now I don't like that. You see that speck of dust right there where the object moved. I'm waiting. Okay, I'm gonna stop. This was good enough, and then I'm gonna take it again to further aside. I'm gonna do it again. 120 seconds, I think, should be okay. Yeah. So, but this is what I say to people about this, because I've been having, we have different fronts. I'm having this discussion with different people, not on my channel. You can find me talking every day about subjects that not all agree with, but this is where I am. It's called Proverbs Guys Ministries on YouTube. And we have a playlist called Astronomy Nights. And it has 3 videos in it where I'm trying to explain to them what doesn't make sense in order for them to realize what we have. Now, it is a ball, but if I put a lamp on top of a table and the lamp is round, that does not prove that the table is round. It only proves...
That for sure.
Don't tell Glober that. They can't understand that yet.
Yeah, they cannot understand.
They can't figure it out.
I know.
It's like they think that
their
because,
brain
it doesn't
goes,
work out.
Yeah.
They think things are
It is
proof
an
that are not
assumption.
proof of anything. It's like, how would you ever say that? It's like, oh, well, we can, the sun sets at 270 on the equinox, so therefore the Earth's a globe. Like, okay, guys. Sure, whatever you say.
It is an assumption. Like what I see up there is round. What is down there, I have no proof that it is. I assume, and I have assumed, just as others did, that it was. But then proof started coming up showing that I can't be so sure about it. And in this channel, we know those proof. Other channels, other places are still fighting, trying to figure it out. I shouldn't even mention to GLOBEBUSTERS fans what I mean. They know what I'm talking about. Now, for me, not having to refocus from Jupiter. No, I'm sorry. Give me a minute. Let me limit this
Somebody
to
in the
less.
chat, just reading some of these chats. Somebody asked, "Doesn't Jupiter have moons?" Yeah, we were just showing them.
Yes,
So-
and we're gonna take a picture of those. But before we do, and I focus on the program that does that, we're gonna turn to the moon, or we should first zoom in further because we can do 2.5 times this distance.
Now, have you ever seen any more than just the 4 main moons that we can pick up with the camera?
Yeah, I think today, as I was browsing to get to the planet, I saw a moon that was very far away, and it wasn't one of these 4. or maybe it was Ganymede. If it was Callisto that we saw that she's so far out today. If that was Callisto, then no, I have never seen any of the other 57 moons that they say that Jupiter has. I've seen the biggest moons on Saturn. If you turn the exposure up,
right,
you can
there's
see
5 Saturn moons. You can see.
I've seen like 3, something like that. But if you look into the finder, not the finder, if you look through an eyepiece and you keep looking around, you can't. But if you bring up the exposure and you start going up and down, you can see that there are some other objects around it. But I've never seen that on Jupiter with my eyes, only on Saturn. Let me show you what I mean.
And so now, just so I make sure, the red spot would be on the back then.
Right now, I see that it's not here. Yes, I think it's not here. It could be that thing on the left, but I can open up.
Is this upside down?
Could be.
Yeah, sometimes the telescope flips things. I don't know.
Yeah, but I've removed the flipping mirror.
Gotcha.
So I think it shouldn't be. But and I have my camera, I think, oriented correctly. It's very windy right now, so sorry for that movement. There's nothing I can do, but it's clearing up.
Hold it tighter. Oh, sorry.
I think the Jupiter storm it's in the up left.
I think so too.
I thought so
too. Oh my God! Stop moving like that.
I guess because I'm not sure what they.
Yeah, the problem is that supposedly nobody see the other side of Jupiter. Not even NASA. The Jupiter always face this super storm, supposedly a storm, of course, and always face that.
Wait, the red spot doesn't go around the back,
right?
Are you saying that the red spot doesn't go around the back?
I never saw that.
I don't know about that.
Yeah,
okay,
and
maybe
one thing,
I am confused.
One thing is for sure. NASA has seen only what you have seen. Everything else is a lie. So
that for sure.
Yeah,
and I think Jupiter doesn't have any phases, right?
Well, no phases. Yeah.
No, but if you remember, when we last time we met, which was on Series 9, Episode 4, we discussed a little bit about this. That although it never has phases, Juno, that was going there, showed us an animation of Jupiter, and it was half lit.
Which one did you say? One of your videos shows that?
Yeah, it is in part F, but it has weird music and some other stuff around it. You know how my videos are like, brother Jeran.
Yes.
But I took it to Stellarium, and the moons were not where they were supposed to be when the animation of NASA was giving us a specific time. I went back to that time, and the moons were on the exact opposite side and in an exactly different. And they are chopping the animation too. It has a cut. If you want to find that, it's in playlist 2016, and it is part F.
Okay.
So now I've centered to the planet. Oof. I've centered on the planet. Now I gotta go around to get the eyepiece. It's far away.
Okay.
So I can zoom further in, and we can enjoy an ever closer view. So this is the image you get with a telescope, and then what we did right now is we took thousands of pictures, and we'll put them on a program that will stack those pictures and will create us a picture.
Okay.
The pictures that you see online are stacked. This is the raw footage.
Right. I hope people realize that, because I think a lot of people think that those images that they show are actual just photographs, but they are supposedly photographs just stacked with long exposures, long exposure times. I'm trying to see if I can. I mean, all I'm seeing is Hubble images of it rotating.
You should go. Yeah, you should go to Astro Bin, like garbage bin.
Okay.
BIN, astrobin.com. And there is a search button somewhere there. And that search button, if you type in Jupiter, you're going to see real images from real people. I still call those people narcissists with telescopes because that's what they do. I mean, for me, when I realized that there is a problem with refocusing, I wondered why so many million of people haven't noticed it. They turn from a star to a planet and they don't have to change their focus. There is only one explanation for that. And you know what that is?
They're all close, same distance.
Firmament.
Oh, yeah. This is according to Hubble, by the way. This is not his. This is Hubble according to Hubble view of the rotation, which I'm a little bit confused of how you could come up with that. Oh, Hubble. Sorry, I'm thinking of something on Earth. Hubble, I guess, could get that if he was real. Okay. So
yeah, I think something was on your throat there.
Yeah.
Well, so while I'm focusing, and we're going to get a better image, I would like to talk about Hubble a little bit.
Okay.
So do you see that the object stays in screen unless I do something to the telescope?
Of course.
The reason that is happening is that the telescope is following the object.
Right.
But the telescope is completely blind. So if I cover it right now, and I uncover it in 5 minutes, the object will still be there, excluding the movement from covering it with your hands and putting the cover on and stuff. That will move it a little bit off. But other than that, a telescope doesn't see the objects. A telescope knows where the objects are because it has a computer embedded inside it.
This is one of the things about solar scopes and Wolfie 6020 that people always talk about. Oh, his telescope just moves at 15 degrees an hour. No, it doesn't. His telescope tracks the sun. It doesn't even see the sun. It knows where the sun will be. That's
exactly. All. This is very important. People must realize that. Now, first off, let me take the gain a little bit down so we see a better picture. Maybe a little bit exposure. And I think we need to... Do you see those little dust marks?
Yes.
This is what... You don't know what a problem that is. The magnifying glass is like 6 glasses. And
you actually have to get in there and clean them?
And then you have the camera, and then you have the big glass of the telescope, so you don't know where it is. And at some point you start cleaning, and then you clean this one, and then another one appears. It's so annoying, guys.
You have to be a member at Astrobin, I take it, yes?
Yes. Okay. My name there is, I think, Creep.
That's
with 3.
For free for now.
Instead of 2 E's, the second E should be a 3. So having a little bit of a hard time because I'm focusing, having a hard time to keep it in the screen.
No problemo.
Okay, we're out. Let's go find a good one. The closer you move in, the harder it is to find good clarity.
Now, does Jupiter change size throughout the year?
Yes.
Okay.
Right now, we are on opposition. So this means it is completely on the zenith of the sky. Like we are almost aligned between Jupiter and the Sun. So this is a good opportunity. After we enjoy a little bit of this view, I think the red storm is on the right. If I take some pictures of this, which should be shorter than 90 seconds, I'm going to take it 60. We're going to have those objects on the screen too, but it's okay. We can ignore them. So I'll press record and hope for the best. Just get out of there. So I'm
What's the name of the program, please?
Go ahead.
The name of the program they use.
Which program?
The program that stacks images and creates star circles and does all that stuff.
Auto Stacker. Do you see my start menu here?
No, I don't think it shows us.
Okay, I'm gonna write this in the chat.
Auto stack, you said?
It is a German program,
Oh,
and
okay.
they have it written in German because Germans.
Yes, we know Germans.
Yep. So let me see. It's 2K. Okay, 2Ks. It also has a mark, and then number 4. It released a new version, Auto Staggered 4. So did we take these images? We took them. So now let's turn to Saturn. And while we're turning to it,
And you're confident that these images on this site are real?
which ones on the Astrobin?
Yeah.
Yeah.
They're just uploaded by people, right?
Yes.
Some of them are crazy.
But when something becomes too crazy to believe, just look who is uploading it, and it might be a NASA person. So
Right.
you gotta be careful. They're everywhere.
Some of them look like, I'll show people this one real quick. I'm looking
Bye-bye,
at this.
Jupiter. I hope you enjoyed it.
I'm looking at these ones here. Oops, why is this thing not in the right spot? Hold on one second. Left this one down a little bit. It's a little better. But I just saw this thing. It's just weird. It's got like a black circle around it. Very strange. But yeah, if you go, and I just signed up for free. People want to check it out. It's astrobin.com. And oops, go back. So then I just saw this main screen, and then I went to search and went Jupiter. And then got all these to come up. So some of them look like I could believe them telescopes. Some of them, this one here is like incredibly sharp. Let's see this one. Oops, how do I get this to come up right here?
So do you guys think Hubble is on the ground, or do you think it's air-based like Sophia?
Probably a plane, I would think.
Yeah, I think it's just an earlier version of Sophia.
Okay, this helps me get back to the discussion about that, but I'm focused a little bit now on the other program, but I shouldn't be wasting people's time with me stacking pictures. But I think I got that, and I need to change. But the telescope went to Saturn, so I should check that out first.
It's one of the show us Saturn. It's one of the things that I thought was strangest about when Miss and I went to an observatory for this big event they were supposed to have, and they have this huge telescope we were able to look through. But we went there, and of course they're looking at the moon, and we're like, "Can we look at something else?" They're like, "No, tonight's the moon night." I was like, "Great," but everybody comes there with their telescopes, and there was probably 25 or 30 telescopes out there. And we could kind of walk around and look into them if we want. And everything looked like you would expect, nothing fantastic at all. But there was this huge crowd around this guy who had this huge telescope, but his telescope was hooked up to a computer. And he was the one showing everybody beautiful pictures. But again, they were all stacked and like over a long time, like, basically took 4 hours worth of pictures and then stacked them or something. But I kept telling him, like, well, can I see that through the lens piece? And we couldn't even look through the lens piece because the camera was in there. But he said, no, it's just stacked images do that.
Yeah. Do you want to bring up the Saturn occultation or Jupiter occultation? So, because we were talking about the refocusing issue, which is also visible at this magnification that we were looking at, but because Saturn is very, very close to disappearing, I want to get to that first.
Okay, go ahead and show that. And then, so I'm looking at your older videos. I scrolled way back, and so I see a bunch of Jupiter. What was the title of that video maybe I'm looking for?
Jupiter animation, or the one.
So I see Jupiter and Moons animation. From 2013,
okay.
Sorry.
This is for telling us and showing us that they do spin. Like that. That is not a lie. They do spin. But that doesn't prove that, here it is. Hello?
Oh, wait, you're showing something? I was showing your video.
Oh, okay. Yeah, I'm too zoomed in. I should zoom out. It's very hard to locate him with such magnification.
Oh, I do see that it does show. So this animation is done by you.
Yes. So what this is
Let me show people real
is
quick.
I continue taking pictures for 2 hours, and then I stack pictures every 60 seconds or 90 seconds, create one frame. And then I stack all of those frames one after the other. And if you make it so it doesn't move right and left, it becomes an animation. It becomes a movement.
Mm-hmm. Okay. Let me move this back because I see you have something on the screen there.
Yes, we have Mr. Saturn, and we're going to fix this right now. He's very, very low on the horizon. I'm going to get this closer to us, and then I'm going to zoom again. Ooh, wrong.
Aren't we getting ready to where Saturn is going to be, the rings will be lined up with Earth, so it'll be like Saturn doesn't have rings for a little while?
Yeah. Which is of, I know they announced this, but it's of absolutely no significance, you know?
No.
It happens.
Well, I mean, the
does it?
whole story about the rings anyway just drives me crazy. They basically say they're a bunch of tiny rocks. They say it's only 30 feet thick. 30 feet, and we're looking at something 600 million miles away or something, so they say.
So, what I would like to point out about our friend Saturn, first off, do you see the waves in front of it?
Yep.
This is the atmosphere because we are now looking almost horizontally.
Some people might call it the atmosphere. Some people think that I'm probably one of them that thinks that that's a liquid up there.
It makes absolute sense because a liquid is a gas with its molecules more condensed. They are the same thing in different form.
Correct.
They can take three forms. One of them is frozen, the other one is liquid, and the other one is gas. So I don't want to go to the Bible that says there are waters up there. You know, I'm a Bible fan.
Right.
But indeed, scientifically, it is a form of water.
Right, and I mean, even if it's a different thing than we're used to seeing here too, you could get to a place where there's zero viscosity, supposedly with the helium and things like that. Helium-3, the superfluid. That's what I was looking for.
Yes, and I've seen those, and they're driving me crazy. I've seen the experiments you've been doing, guys, and they're blowing my mind. I didn't even know about the superfluids going up and doing those crazy things.
Incredible, because I know Iru is under the same thought process. Iru thinks that
in this case we are looking from the ground to the sky, and we have like 35-40 kilometers of gas before reaching the image. So this will be very nice if someday we can have like a gondola up in the sky and take a telescope with us and trying to see planets and start
without the atmosphere.
From 50 kilometers.
So it sounds like they should maybe put
ground,
they should put a telescope on the ISS. So you imagine that? It's only been 21 years.
Yeah, we have the astronaut, this woman, I cannot remember the name, that she said that with a telescope outside of the ISS, she can look black holes.
Oh, goodness.
Remember?
Fantastic.
Kathy Coleman.
Oh, Kathy, yes. And then the other, it almost came in.
This is like the best picture we can get. I've been trying to zoom in and out, but it's so horizontal that we cannot take we cannot see a clear image.
And how close is it to the horizon right now? Like less than 10 degrees or no?
Yes, much less. Yeah,
I don't think you're supposed to even
it's
look
very
at
low. But this is what I do wanna. My planning for this night included this problem. So do you see that there is red at the bottom and blue at the top?
I do.
You see that we cannot take a picture. Even if we take pictures of that, we will get a blurry image that has nothing to do with what Saturn looks like.
Okay.
True. So let me get, first off, let me get my my thermos with the coffee. 1 second. I'll be right back.
Sure. Iru, just to show you this too, this is 2 different dates showing the size difference of supposedly This one taken, it says November 30th. This one taken August 27th. Supposedly. Again, I'm going to keep throwing supposedly in there as much as I can.
Yeah, the word supposedly is very important these days. So,
according to what they say. According to what they say.
Yeah, if you watch a documentary in any channel today, you should print supposedly on top of the screen.
Yeah.
So, I mean, everything is an assumption. So, do you see this problem that the atmosphere creates?
Yes.
I want to tell our viewers that this problem is there because of the refraction of the atmosphere, and I have the visuals to show you what that means. Do you see my desktop and stuff?
No, now I just see a frozen image of the Saturn.
No, so that's weird because I don't understand how to deal with Skype. Let me see.
Let me stop sharing for you, and then you can. Let me see if I go share screen.
I think what I have to do is click here and say stop sharing.
Yeah, so
or switch screen. Okay, so it chooses the screen that I want. That's so interesting. No, I just want my computer. Oh, desktop.
Oops.
Okay, so now we got the desktop. Now you can see my desktop. All right.
Yep.
This is the telescope.
Oh, I'm sorry. I didn't know you wanted to show that. Let me get it back on there.
No, it's okay. I don't mind.
Share. Okay, so you're back on. There's the telescope. Gotcha.
This is our telescope, and the view, the short view was the finder scope, is the one on the top, the guide scope. So I will now open up some pictures, which I should have somewhere around here on my desktop. Get this out of the
and it's a 14-inch. I thought it was 14-inch didn't exist, but now I know it does.
It's the biggest one I can carry. The others need to be positioned. You can't carry them around. So where is that?
Would you say the
picture?
weight of this one is? Did you say something like 250?
160 pounds
160,
with a
okay.
tripod.
Yeah, not very light.
Not very light, no. So why aren't they here? I can actually go to.
Go ahead, I can bring some of them.
I can go to just Google. Can you see my browser now,
Yep.
or is it just?
No, we see it right?
So the object that we were just watching.
You can go to your bank account if you want and enter your username and password. We'll watch it.
The object that we're just watching is inside the solar system. It's not a star. It's not as far as a star is. So we cannot get a clear picture of that object if it is on the side of the horizon. Again, I need to check if I can have that picture. I should have a directory here. New folder, maybe here.
I'll bring up something while you do that.
Yeah.
Tell me when you're ready. So this is just pulling up. This is more from AstroBin. These are, I just typed in Saturn in the search. Kind of a cool site though. If anybody wants to go here, I just signed up for free, and then now I'm able to just use the search. I don't know if there's something. Ira, what do you want me to search? You name it.
Not me.
Nobody else.
A planet or what?
I don't know.
No. Well, but you can put.
Yeah,
Mars.
we'll put Venus and see if there's a so
Okay,
people can see the
Venus.
phases there. I guess I'm sure that they'll show them. So I just typed in Venus and we get this. Is that a phase? God, I hate they put. Oh yeah, that's kind of better. So that's kind of showing you that there's a little bit of a phase there. You can see it's, the dark half would be over here. And again, for like the Tycho system, and what I think most flat earthers believe is that I believe personally that these lights do orbit in the sky, but they orbit above us and they orbit the moon. I'm sorry, they orbit the sun. So Venus does go around the sun, etc. But that's just me. Again, it could be. I'm sure there's many different opinions.
So I did find the picture I was looking for, but not on my computer. I found it by Googling it. So this is it.
Okay, let me pull it. Hold on 1 second. Okay, we're looking at that.
So the object separates its RGB because of the atmospheric refraction. That's why to record an object, we are waiting for it to go on top of the atmosphere. So when it's around midnight, it can be on top of you. and you can have the less atmosphere between you and the object.
Correct.
If that doesn't happen, then you get this dispersion. It's called atmospheric dispersion, and what it really is refraction. In order for someone to understand it, it is the same thing that is happening when you put a pencil inside a glass that has water in it, and when it changes element from air to water, it refracts. So now that we know this, I'm going to take us to a video by this smart guy.
No. Sorry.
Yeah, seriously, no, don't. So this is how we measure stars.
Yeah.
We wait for the Earth to come on this side of the sun.
No assumptions
And
in
then-
this either. It's all fact.
Exactly. And then we wait 6 months for the Earth to go to the other side. And then, because we know the distance to the sun, which is an assumption, but let's say we know it, we have one side, and then we have the corner according to the vertical. The star is not as close as Saturn was.
Mm-hmm.
So if you bring the vertical of the star to the sun, I think he does that a little bit further down here. Come on.
And then just so people know, those angles, by the way, the angles end up being, on the orders of tiny little milliarc seconds, which is, you take an angle, you take a 1 degree and you split that into 60 and you get the 60 minutes. And then you take that 1 minute and you divide that into 60, you get 60 seconds of arc. And then you take that and divide it by 1,000 to get to milliseconds. And that's how small these angles are. So you're really talking about 89.99993 and 89.99994. Those are the angles to the star, even though right here in this image, it looks like the angle is drastic.
Big.
Yeah.
Yeah. This is so important that Jeran said. Yeah.
Could your telescope pick up an angle that small, like a measurement? I know it has measurements on it, but milliseconds are ridiculously tiny. I would think that that's just the giant observatories that claim to do that stuff.
Yeah, no, we're about to prove what a lie this theory is. What Jeran said is the good introduction to it. And now I will proceed with that. No, I have never tried that with a telescope because they are lying to you. Not to you, you've already woken up, but to those, the Wikipedia people, they are lying to them that they have these big telescopes that they can do that. Well, I have a big telescope, and getting the number that Jeran just described is, I'm not a god, this is like a point 1. You guys are kidding me.
Right. Through an atmosphere, by the way. They're looking through the atmosphere. So it's moving around, it's refracting, and yet they're going to tell you the distances from there.
And this is where the problem is. First off, let me mention that we get here this distance, which is approximately 70,000 miles. 70 million miles. Oh my God. But the distance to the star is many millions of light years. So if you draw that triangle, it doesn't look like that.
No, I can draw it on a little screen here so that it's kind of
You
funny.
cannot even draw it. It's like you are moving from your bedroom from the right side to the left side, and you're trying to measure something that is on the other side of the United States.
Right. I talked about it last week that just to give it an idea again, that if you were to shrink the sun to a golf ball, so kind of picture that, you shrink the sun to a golf ball size, then the Earth is about a grain of sand, about 10 feet away. Okay, so you have the little tiny golf ball, then you have a grain of sand 10 feet away. So if I asked you where the next star would be, how far away do you think from our golf ball the next star would be? And, many people will guess, is it a half a mile? Is it a mile? Is it 10 miles? That'd be weird. A little golf ball and the next star is 10 miles from that one. The actual answer is 750 miles. Okay, so you have one golf ball and a little grain of sand, and we're supposed to believe there's some assholes on the grain of sand that are so smart that they're able to look through their little glass tubes and then figure out the distance of the other golf ball, the closest being 750 miles from the golf ball.
Yeah, just to help with the scale, this is, you can see my screen, right? This is Earth. Let's say that where Mars is right now is where Earth is going to be in 6 months. Okay, almost there. It should be like right over there. So let's zoom out and realize that we just hit 10 astronomical units, 100 astronomical units. Astronomical unit is the distance to the sun. 1,000 astronomical units, 10,000, 1 light year, 1, 10, which these stars are supposedly at 10 astronomical light years away, 100 light years, 1,000 light years, and they still giving us stars here, telling us that these are the distance. And even if I go further out, 10,000 light years, and they are telling us that there are stars millions of light years away. We are just at 100,000 light years away, and we haven't even escaped our galaxy. All right, the galaxy is like half, is almost exactly the distance of the radius, which should be 50,000 light years. So people should wake up. This triangle, one side of it is so small that you cannot do that calculation at all.
Yeah,
like not even with a supercomputer. But let's now focus on something much easier. So the reason that we could take a very good picture of Jupiter is that this is where the sun is, and this is where Jupiter is. I could actually turn to Uranus, and by the way, this is how to pronounce it, so no funny jokes are made. It's Uranus, all right? So in order for me to take good pictures, it has to be in the darkness. The darkness is around here, and this side is where you guys supposedly are right now, and you have the sun on top. But I am on the other side, and I have the darkness. So in my darkness, I have Jupiter, and I have Uranus. And if I turn to Saturn, you will see that it is right in the twilight zone. It's on the side. So if we go, before we go, let me clear this again. This way is daytime. Mm-hmm. The other way is nighttime. So the closer to when Jupiter would be, move Jupiter, why don't you move? Why do you always only move the other way? Oh, come on, I'll move the Earth then. So this would be the perfect time to record Jupiter. This is my midnight right here, okay? This is noon, and this is midnight. So when the Earth spins, supposedly, and goes that way, that's when you get the planet on your zenith, on your sky, mm-hmm. because it is right at midnight. But let's go back to measuring the stars. In order to do this measurement, we just explained how silly it is anyway.
Well, I can show them real quick on this. So just keep that up there. But yeah, and like this diagram here, they love to tell you that what's happening is that, oh, we measure this and see what background star it hits. And then we measure this and we see what background star it hits. Remember, this would be 6 months later, the Earth's in some sort of orbit. And then they would say, oh, so then we can figure out from here, because you basically draw this line. And from there, you can do your triangle mathematics to figure out the distance. But the problem with that is the actual truth is that this line ends up being like this. And this line ends up like this.
Exactly.
And yet that's a triangle. See, because this is a triangle. Here's your baseline. And then this is the arms. And this would be the arms of the triangle. So if you got down in here and you were actually doing your measurement, that the angle here would be 89.9996
to infinity.
Yeah, it's going to be like something like this. And just to think that we can see, oops, that was a lot larger of Okay. You put this down there.
Okay.
Put 55.
Yeah.
Anyway.
Technical difficulties.
So you go 89.9996 would be like there, and then this one would be the same, 89.9993, and then from that you would figure out the. But again, there's no verification of this. What they want you to believe is that parallax.
I think you're too lenient on the nines.
Maybe it's more than that.
Like
I don't know what
10
it is.
more.
It's a lot of nines. But yeah, they just, again, parallax on Earth works because we can actually verify the distances, and nobody's doing this kind of angle, right? So think about parallax on Earth. When you're talking about looking at an item from two different locations, they are going to have crossing paths, meaning that because parallax does work well sometimes. Let's say you've got a river here. Whoops. Sorry, I just draw that. So let's say we've got a river here, and we're out of of course, it's not a pink river. It's going to be blue. Okay, so we got this blue river, and we want to figure out the distance across this river, but we only know how to look at an item like here, this pink, let's say let's call it a tree, just for, there's a tree. Okay, so we got this tree over here, and we need to figure out the distances of across this water. What you can do is, if we measure this baseline, and then we take the two angles of this guy going this way, and this guy going this way, and then you can get, with your arrow this way, get the triangles and figure out the distance to that tree or across the water if we had something over here. So it does work, and we can go verify that on Earth, but we're not ever dealing with angles so stupid as 89.999994. No, you would never how would you see it on Earth? It's impossible. Nothing would ever be displaced like that. But they pretend like they can just do it. And then and I'll keep making this statement until somebody proves me wrong. There's nobody who's a globe believer on YouTube that has ever done any kind of stellar parallax or has ever seen somebody do it. Just like nobody's ever seen spectroscopy, nobody's ever done it, nobody's ever seen somebody do it. So just be careful on what we believe. If we have never seen anybody, even the guys promoting it and laughing at you have never done it, never seen it. So it's pretty crazy. Okay.
But they're telling them that there are scientists that have.
Right.
Oh,
of course.
Well, that is not science. That is faith.
Right.
If you're telling me that somebody has and you can't, but believe me, that's faith.
Yeah, and especially if you're telling somebody they can do it, somebody else has done it, but then you're like, well, can I see somebody do it? Well, no, we just have to trust them. There's nobody there's nowhere even to go. Where are you going to go and look at that?
But let's now ignore this for the viewers, and let's go to how stupid this is. Before we even got to that level.
Okay.
In order for this to work, we have the angle here, and we have the one side. So supposedly, because it is a square triangle, we have this corner here being 90 degrees. We can figure out the other tilt, and we can figure out the sides, and then we can figure out with the we use sine or cosine, and then we use the Pythagorean theorem, Pythagorean, yeah, and we figure out the side. But here's a problem, a practical problem. Where is the night? It's on the other side of the Earth. Mm-hmm. So we are looking through the daytime, not even in the twilight zone. Like if I were to draw the twilight zone here, wait a minute. Should I? Okay, I'm sorry. I wasn't seeing my mouse. I had to do with the window of Skype, but now I see it. So if I were to draw it here, if somebody takes a screen of this right now and puts it in the Paint program or something like that, I can do it actually. Shift S. No, because this is not VLC, and I don't know with this one. Save image. Okay, let's save the image. Okay, so let's go to pictures. Okay, and let's open it with Paint. The good old Paint. So please move out of my way. I can actually close this window. I hope it doesn't.
No, that will, I believe, will shut you down. That's
okay, is it that one? Oh, stop sharing. And this one, close. I think this should be it. Close.
Okay, try it.
Am I here?
Okay, you're still there.
Okay, good. So let me draw the twilight. Not with this one. And I'll press Ctrl Z, and I want it to be straight to I want to take a red color, make it bigger. I'm holding down shift. Okay, here we are. I said red. Okay, so this is the twilight zone. This is where we were looking at when we were observing Jupiter, Saturn. Here, I need another brush, something like that. Okay, here, this whole part, sorry for, my hands are freezing. And okay, this part is darkness. This part is daytime. It has the sun. So in order for this triangle, which is supposedly a square triangle, getting annoyed, but again, okay, we're supposedly getting this corner being 90 degrees, and that's why we can do the measurement. But the truth is
that's ridiculous.
Isn't it? We're not even looking on the twilight zone that creates the problem of refraction, and we don't really know where the object is. We are looking into the daytime in order for this triangle to be possible. Because if I was looking at this star right here, or let's say a star up there, and I draw the lines to it from the Earth to the other side of the Earth, this is not a square triangle. So there is no way to figure out the measurement on a triangle that is not square. So I'll press back to delete everything I've done here. And show again that we are looking through the daytime. So if their telescopes can see stars in the daytime, oh, they're better scientists than I am. I mean, I can't. I have to wait for the night to come to see a star.
Yes.
So without even taking into consideration the triangle, that the distance that we just described, the whole thing doesn't make sense.
No, I don't even know how you would know to say that the star's at 90 degrees of the sun anyway. Like if the star's a little bit off to the side now, then all of our angles are screwed up. We don't have a 90 degrees anymore, and it just becomes convoluted. But until I see somebody do it, I'm not believing in it at all. Again, we had Tycho Brahe basically say, oh, none of that would work. You need the stars an infinite distance away. And then somebody killed him, and then they came out and said, oh, the stars are an infinite distance away. So it's like it's always piecework too. It's like they do everything mathematically. So they can do on the paper, they can figure out, okay, well now we'll put this star, it's at 90 degrees of the sun, but it's all done on paper. It's not in real life. And then if they tell somebody to go out and measure this angle, then they come back and say, oh, I got exactly that angle. I got 15 milliarcseconds. Oh, sure you did. Sure you did.
Okay. So even I found the pictures finally. Even at the twilight zone, this is what happens with the refraction. On the side, we have a correcting object that corrects the refraction, but still you're looking through the atmosphere. Even at the twilight.
So that's like red shift and blue shift is what we're seeing?
No,
okay.
It is the refraction. It separates the object into three objects.
Okay.
What we just saw with Saturn, which is this picture here.
Right.
It separates it. So let's say they even have tools, I imagine they do, to fix that. Okay, but still, you're not even looking through the twilight. You're looking inside the daytime for the triangle to make sense. Because as we saw on the program here, all these back here are the stars that we can actually observe. But if you were to draw a triangle of a star out here to the Earth, and then the Earth being here, that would not be a square triangle. The square triangle has to be exactly on top of the sun, and in order for that to happen, the triangle doesn't make sense. Here's something interesting, but I should.
Plus, they believe in like curved space-time, and I mean, imagine that. So now we're just measuring angles straight lines through curved space-time and thinking that we can come back with distances for people. It's insane.
Again, another picture that you see, people focus a lot. First off, the picture that they have here and the picture they have here, they are lying.
Absolutely.
Notice the distance. This is not happening. What is happening is that it is moving so slow, so minimally compared to where it was, that they say that only they can measure that.
Well, and what's really happening is if you think of the stars above our heads turning in a disk, 6 months later, they're in a different location. So they're going to be off a little bit. They're going to be off versus, because think of where the sky would be 6 months after where it's at now. Yep. You would be able to measure that little tiny change. And if you're saying that that's because of when really it's the sky moving, not you.
Completely agree. But still, here is another picture that completely exposes the problem, but nobody focuses on it.
Right. They even show the dark side.
Look where the line is drawn. Is this daytime or nighttime?
Right.
Like they've even made the mistake here of doing the nighttime.
Yeah, because now you have me thinking, how would you ever do it 6 months later? No matter what, you'd always be on the other side of the sun. So the night and day should be swapped. Like, I get it if you're looking at Polaris or something. Polaris might work, but nothing else.
100% true. 100% true. You should move to the other side of the planet to do it. Planet, supposedly. But you should move to the other side in order to do that.
Not from the same location. That wouldn't even work.
Oh, actually, no. No, because according to the spin, you will get at daytime and nighttime all the countries. So no, let's say that is doable. But the thing is that the line is drawn in daytime. This is so important, and people need to realize this is daytime. Why don't I can zoom, but I cannot take it. What's wrong with you, Windows? Oh, I can grab it. Okay, so I zoom in again. It's
daytime.
This destroys everything. Like, there is no way to take a measurement of a star during the daytime. But people want this channel to expose that. They don't think for themselves. So I hope we are helping some wake up from the deception, because they are lying, and all we're doing is we're exposing it.
All right, we're not straw manning them or anything. Here's a page I just looked up, stellar parallax to stars, just so people can see that in every case they draw an exaggerated bullshit example. Never once do they show any kind of example that would actually tell people the real angles being measured here. Yeah, according to this and on the Earth, this makes a lot of sense. Oh, the star is here and then it's here. But this is not at all what is being claimed. They just want people to believe this is how easy it is. Oh, we just look at the star here, we look at the star here, and therefore we can figure out the distance. No, why don't you show people their actual triangle has straight arms of 89.9999994 degrees, not like these angles are ridiculous. These angles are like 45 degrees, not 89.9999999. And then they have something called the standard candle, which is just a joke. It's like, oh, well, we use these known stars with known brightness. What do you mean? How do you know? You mean you all got together and decided? Because you didn't go there, so you can't know anything. But they, I mean, these are just so off. It's, these lines would be like this, straight. And I don't even see it one time.
Because the distance to even the first star, the distance is so big that the line is straight.
And I'm trying to find one image of them.
And the side, there is no true one. And if you also take in account the distance we have to the sun being 1/1000th of a light year, then imagine that triangle.
Right. Yeah, I don't see any. It's just showing you that all these are just basically nonsense.
So let me go to another subject. I think if somebody has a couple of brain cells that work together, this one is done. If you agree with me. Now let's go to another one. We were watching Jupiter. There's something between us and Jupiter, though. if you look here, the asteroid belt is right between us. Did you see any rocks between us and Jupiter?
No, but we can see the rocks of the Saturn ring, right?
Yeah, we can see those. but both Saturn and Jupiter are so bright objects that if there was a rock in between, it would make a dot. It would make you would see something dark there. So if somebody goes to Astrobeam or the Space Weather Gallery of spaceweather.com, you will find 100 pictures of Saturn, of Jupiter per day, because today Jupiter is observable. Saturn, it is too, but not at the hour that we've started. But anyway, you can find 100 pictures of Jupiter and 100 pictures of Saturn today. If you go back one day, you will find another 100. If you go back one day more, you will find another 100. There has never been observed a single rock between us and the object. So if you were to go to Wikipedia, and this is the asteroid belt, and supposedly this is where comets and objects that we see moving in the sky, they come from, they bounce on each other, and one of them leaves and comes to the Earth, close to the Earth, which is a constant threat to keep you afraid and paying NASA to protect us.
Of course.
And the other one is the Oort cloud. Unfortunately, this program doesn't allow you to unhook from the sun, so I cannot go all the way out to show you the Oort cloud. But if I go to, oops, I was in my browser
Explorer
already.
is out there in the Oort cloud.
If I go, just type in Oort cloud, and we go to, I'm closing this again, Wikipedia. There's a magic word here. It says the Oort cloud, sometimes called that cloud, is theorized. It is theorized.
No, our telescopes have seen it. Oh, maybe not.
Which, yeah, their telescopes have. Mine hasn't.
I don't think theirs has either.
Yeah, they have better telescopes than you do. So, yeah, they will say that they have better telescopes than you do. I bet they do. I mean, they named them Lucifer.
Right.
They have to be better than mine. I can name mine Lucifer. I think that's very blasphemous and anti-Christian thing to do. But they are doing it. So they do have better telescopes than I have. But still, there has never been a single picture of, I think I can open this one and zoom in. Yes. So this effect has never been observed once in the history of mankind. I have never seen one picture of one rock passing through Jupiter. And in case you don't notice, there are many rocks right there. I mean, it's not like, it's one rock, you would miss it. I mean, I understand why I can't look into one of them in the night. It is impossible to find it when the background is black. But when it goes through such a bright object, it should be there.
Yeah,
For
and it
people to
shouldn't be lit
understand.
though, too, because I mean, if the
You know-
sun is shining on it, why wouldn't it light up like the sun shines on the planets?
It should, but because we have another object behind it, let's say it should just hide the brightness of that object.
Right, like kind of appear like a silhouette.
Exactly. So for the viewers, they should realize that we should have right now pictures of Jupiter that they were brilliant, but there would be a rock in the face. And people will be like, yeah, I took this brilliant picture, but there was this rock from the asteroid belt in the middle, but the name is Vesta or whatever. We have never, ever had that. So poof goes the asteroid belt. It doesn't exist. If it had existed, we would have seen it at some point. One astronomer would have one picture of one rock between us And then, so I like this. I think people should read this. It's a spell against us. People need to wake up. Everything is turning around us, not around the sun. But I shouldn't even be saying this to GLOBEBUSTER fans. They have already realized this. This a friend of mine, a subscriber to you too, asked Chat GPT, what are the assumptions for the parallax method? And Chat GPT responded with
wow,
10.
a huge list.
Yeah.
Go back to number 1. I just want to see some of them. So this is the 10 things that are assumptions. Earth's orbit, yep, that's an assumption. Nearby stars. The parallax method is only applicable to stars that are relatively close to the Earth. Relatively meaning trillions of miles away. Accurate position measurements, right. You'd have to know exactly where you were at exactly the right time. It would just be impossible. Negligible atmospheric effects, never going to happen. No proper motion, not even true. That's basically saying the other stars don't move, which they do. I'm at number 5. You can scroll down a little bit.
I'm sorry.
No problem.
Yeah, I was moving to the telescope to.
Okay, go ahead. Go do that. We're done with that. It's just good find.
Pressing play.
Single stars. Parallax measurements assume that the observed object is a single star, which sometimes they don't even know if it's a double star. Accurate time measurement. Remember, these guys were doing these crazy things back when we had pendulum clocks. Proper calibration. Of course, if you have any kind of aberration in your lens at all, it's going to be a problem. No relative motion. This method assumes that the star being observed is not undergoing any significant relative motion with respect to the sun, which it's moving millions of miles per hour, supposedly. If a star is moving rapidly through space, which it supposedly is, the parallax method may not yield accurate results. And then we've already seen before that they actually have a technique for what to do when you get positive parallax. Okay. So, I'm sorry, when you get negative parallax, which should be impossible. There's no way that
negative
could be
parallax.
Yeah.
Wow, what would that triangle look like? Because
there's no such
the
thing.
parallax, yeah, because the parallax by itself doesn't say anything. What happens with the method is that because we have the triangle with the sun, we can do the measurements, which is sine, cosine, and the Pythagorean, and then we can say that this is the distance to the Earth. But that only works on a right triangle, on a triangle that we call a square triangle, the one that has one corner being 90 degrees. If that doesn't work, then the whole method fails. But people don't look into it, and that's how they've created this faith of scientism and globalism.
And how about this? This is from a astrophysics paper from 1943. Talking about on the reason for the appearance of negative parallaxes and the determination of distance of stars. And it basically says everyone who has done any considerable determination of stellar parallaxes by trigonometric methods has occasionally found that the usual procedure gave him a negative parallax for the star under investigation. So long as its value does not exceed 3 seconds of arc to 6 seconds of arc, he may be reasonably content, for the parallaxes traditionally assumed for the comparison stars are about this amount. So the final parallax reduced to infinity is a small positive quantity or zero. They basically tell you to take your measured negative parallaxes and shove them up your ass and return them as positive parallaxes. Because, you know, the final parallax reduced to infinity is a small positive quantity or zero. So these are them telling, this is what it has to be. So when you get the negative, sorry about that, it says now and then a negative parallax turns up, which may be 2 or 3 times the size of the internal probable error for determination. And this value may be modified by making another solution with measures on another set of stars. The mean of the 2 determinations is usually given and may be exhibited for publishing. There's basically just tell them do something until it comes out positive. It's ridiculous.
Yeah, and this was figured out, in the 1830s? I think James Bradley, they even have a special name for it. They call it stellar aberration. And yeah, they even say in the notes, you mark it as a 0 on the main data sheet, and in the side note, in the the memo part, you mark the actual negative amount.
Yeah, this one here says a large negative parallax may be just as real as an equal positive parallax. So it must be merely recognized that it is the positive parallax of the companion stars with which we are seeing. In fact, a certain amount of direct information about the distances of fainter groups of stars such as this are used for comparison purposes. It's basically telling you when you get a negative parallax, just make it positive. Because it could well very be the positive. Because it can't be the negative. The negative, would destroy our model. So therefore, it is positive. It has to be. Because you're probably looking at a double star and you just didn't get the right stars right. So that's how we erase that. It's like insane that this is what is considered science. But this is this. Oh, what is that? This is the same thing that they have done. What is it? What are we looking at now?
A donut in the sky.
Yes.
Yeah, it's out of focus.
I'll take an old fashioned.
We just turned to Uranus, and I only had very high exposure in order to find it. It's not easy. It's in the glow of the moon. So unless I'm not mistaken, because it doesn't look like it. No, it's a star. It's a star. And unfortunately, Uranus is so close right now to the moon that is very hard to locate. So I saw a dot there, and I thought that was it, but it's not. It's a star. Otherwise, we would see a blue dot around 10 times bigger than this.
What is
I'll try to find.
Okay.
Go ahead.
No, I was going to say. So, what is the reason why planets don't flicker but stars do?
I think that if we forget the solar model and we realize that whatever material exists, it goes all the way to the star, there is more of it. So I know one thing that doesn't make sense, which is that we can never zoom in a star. No matter the strength of our telescopes, the star will always remain a star.
And people don't even realize that even like I've heard, what's his name say at Vsauce, that nobody has ever in the history of the world seen a star as anything other than a point of light.
Yes.
Exactly. And that is why you cannot see, because, for example, there is a lot of people that film planets with a poor quality camera, and they have this chromatic aberration or this feeling that there is underwater and you can see flickering the planet. But that is based on the camera resolution, the size of the lens, etc., etc. So maybe we have technology in terms of the optics that is capable to reach the correct focus for the size in terms of the angular size of the planet, but not for the star. And maybe the star are just, tiny point of light like we see. So the maximum thing that you can have in the star is the you're gonna fight with the chromatic aberration, but it's always gonna be like a tiny point of light.
Yeah.
And they are telling people that they can see this dot, that at some point it changes brightness for a split second.
When the planet goes by it.
So it's a planet that goes by it. And they are telling us that they have a way with the Kepler telescope and everything else to measure that being periodic. Well, this cannot be observed by you.
No.
Or anyone with any sized telescope. You have to trust them that it's happening. I mean, on that dot, if I zoom in, it will still be a dot. Now, what I'm going to do is I'm going to turn my camera to much longer exposures. I'm going to turn it to deep.
And just we have about maybe 15 minutes or 20 minutes left. So anything you want to show, make sure you get it in.
We should be able to do this. Again, I'm going to refocus a little bit because we're going to try to take a picture of what's going on there. Not exactly a stack picture. But brother, I will send you the stock pictures of Jupiter because we had things to talk about, so I didn't get into the stacking software.
Okay.
But you can show them on the next show, or we can continue this discussion as a part B. There are much more on astronomy that prove that they are lying to us. I think today was a good start.
Can you show that image that you have of the moon with the planet behind it?
Yes, and it's not mine.
Okay.
But if we go,
I remember you showed that, and that was a pretty good, because you said we couldn't be in focus of both, right?
exactly, they are so far away. And look at this picture.
It's supposed to be
let's
real.
Look at this is also a video, if I'm not mistaken.
Oh, wow.
Yes, it is. Yeah. So I want people to realize as they are watching this how far these two objects are, and they are both in focus. This should not be possible.
That's a beautiful. It's a beautiful video, man.
Yeah, I didn't do it. Somebody on the internet has. And it's insane. I would like to show you a video of NASA about from Juno, which although it would have supposedly crashed on Jupiter by now, it keeps sending us pictures. I don't know if you've heard that they power hacked the Voyager.
Yeah, they sent an update.
They send an update in the batteries, and now it will keep going for another 20 years.
One day we'll be able to update our phones from outside the house.
Yeah,
we can't do it
remote
right now, but
power hack. I mean, I had never heard of that, and I want them to do it to my car, when it runs out of battery.
just fix it remotely.
And I want to know what programmer they got to do this, because I don't even think we had DOS back then.
What are they using?
Yeah, what are they using? What kind of code are they using to write this to send to this thing that it can actually read? Because, yeah, I've talked to Jeran about that. Because, yeah.
So I'm sorry, go ahead, brother.
No, go ahead. I was just going to ramble on about how code has changed over the years and how it's like a different language. So, yeah, getting this done.
Yeah, according to when they sent that, because I am a programmer, they should be using BASIC or even Logo. No other language existed at the time that they sent it. C and C++ came after Pascal, and I think Pascal was around the 85s. So this is a very good question. I mean, they should be using BASIC. This is the second language that existed. The first one was Logo. You could only draw with it. And then there was BASIC. And yeah, it's just dumb.
Here you go, Guyana Space says, please give me the link to Voyager getting updated to last longer. You do know that Google works. You could go type in Voyager update last longer in Google and it would come up, right? I mean, you understand how search works. You don't need to ask us to do it. But I just did it for you. There you go. That is the space.com article that's telling us that it got its update. It's what does it say? I just saw the crazy story too. What does it say? Hold on, let me check it. I just check it. So it says NASA's interstellar Voyager probes get software updates beamed from 12 billion miles away. That's incredible. About 46 years after NASA's Voyager launched an epic journey to explore space, the probe's antique hardware continues to receive tweaks from afar. One update, a software fix, ought to tend to the corrupted data that Voyager 1 began transmitting last year, and another set aims to prevent gunk from building up in the spacecraft's thrusters. Okay. Together, these updates.
How can code do that? How? What?
You program it for like a little dust bunny to come out and then like dust buster and it like rubs it off. It's really cool. That's insane.
I mean, that's Mickey Mouse, guys. You gotta just realize that's just cartoons.
It can only far into the mission, the engineering team is being faced with a lot of challenges for which we just don't have a playbook, but they continue to come up with creative solutions. Unbelievable, amazing stuff.
The recent news is that they power hacked it. Like its batteries would run out because the distance to the sun is so big that it doesn't get any power in the solar panels, But now we power hacked it. And I talked with an atheist and a Wikipedia dude the other day, and he said, "Oh, that's because it also carried an atomic energy thingy." Yeah, okay, but if that runs out, how do you power hack that? How do you send power through the space?
Crazy.
It's insane. So here is an animation. You saw the animation that I did. This is an animation from NASA, from Juno. And if you will see, I will have to be pausing it because I'm afraid of copyrights, although I've muted it because I know that the music is copyrighted, but I'm not sure about the visuals, so that's why I'll be pausing it. You will notice that this is the moon, and it's Europa, and it's coming closer to us.
This supposed to be real?
Yes. Yes. Okay, but wait a minute. Why is it now going further away? Who changed? What happened? I'll take it back for people to see this again. I mean, it's coming to us, so we're going to it. We're about to crash on it. But something changes here. Oh, and then it goes back. So what happened? How did that happen? We thrust away? Because I don't see any difference with the planet. Nothing changed on the planet to the right, but the moon came all the way to us, and then it started getting away. But I want people that are watching this to look at the bottom right of Jupiter as I will press play. Do you see those little star thingies over there? So focus there and see what happens. To see how real this is. What?
Yeah, so
what just happened there? Did the planet just turn?
This is supposedly a real raw image or photostat. This is not a compositing. This is not.
No, this is supposed to be from NASA's mission there.
Yes, from Juno.
No, I remember the mission. But I when I see this, I mean,
everyone knows what fake looks like. It's like when I look at the Cassini images of Saturn. Is that it's so bad, it's so fake. I'm embarrassed for humanity for even believing it. Like, I get it that you're like, I don't think governments can lie. I don't think that space agencies can lie. There's too many people. But when you look at the images, you can tell that they're fake. So what are you doing? Why would you give them all this and just be like, yeah, the images look fake, and yeah, I've never seen it done, and yeah, I don't know anybody who's ever seen it done. I've never even watched somebody do it. Like, start naming all the reasons that we have not to believe this stuff. And the only reason we have to believe it is because we don't want to be made fun of by the people who do. That's basically it.
Yeah, that's basically the reason. People don't want to be on the small group.
No,
we have a tendency to be with the winner. Quotes.
Schools taught us that, right? Schools taught us that if you ask a question, then you'll get laughed at by everybody. If you don't believe what the class believes, then you'll get laughed at by everybody. School teaches us real quickly that it's better to be with the crowd than against.
And that's why it's happening, exactly. So in the next couple of minutes, we can get the picture of Jupiter. It's very close. It's not going to take us a long time.
Oh, it's stacking them right now?
Yeah.
So here's another funny thing that I've just been thinking about lately. I forgot whose post I read, but they said some of the stuff in there, and I just really started thinking about it like, oh my goodness, it's so ridiculous. So they tell us that there's no such thing as a free energy machine, right? Free energy doesn't exist, that you always have to get back less than you put in. Okay. But then they have this thing called gravity. Okay. Now think about it. Now we're supposed to believe that every item, find something near you, pick it up, that item is a free energy device because it always has a pulling force that comes from where? We don't know. It's that each item has its own perpetual forever given to it. How did we know? We didn't even know how it got it, but it's got it's pulling, it's using a force to pull things to it. That's insane. That's insane that they tell it no such thing. It can't have free. Oh, except for our gravity that has no opposite. There's no, it's just gravity just pulls. It's a never ending, perpetual free energy making apparatus that gets its power from its own self. Go pick up a rock in the front yard, and that rock is a free energy perpetual device that is always has a force pulling to it. Incredible.
Yeah, which is a continuation of the nonsense. That, like, if you go all the way back and you take it from the beginning, It's nonsense. If you start on the Big Bang is a big explosion, and explosions create hydrogen and helium, and what else? Do they create gold? Do they create uranium? How did we get all the other elements? So then you move to stars. How do stars form? Oh, they gather the elements from around and they pull them together. Yeah, but wait, for gravity to work, there must be something there to pull the things together. If there's nothing there, how do they pull themselves together?
Right.
When you ask about where the elements came from, they will say from the stars. Yes, from fusion in the stars. But we have never managed to fuse past iron. And in order to have the stars, to create the elements, you need the elements to create the stars. So nothing makes sense.
No, it doesn't. I mean, just the simple fact of we know what gas does in a vacuum, which is expand. Okay, so then give us one example or one demonstration of gas doing the opposite of that, which is at some point it gets so big that it's like, now I don't want to expand anymore. Now I want to come into myself. And that when he asks that, they say the stars. Like, no, I know that's what you say happens with the stars. I'm asking you for an example of that. Nope, all they can give you is that's what the stars do. So the stars, so we know what gas does. We put it in a balloon. We send the balloon up, and then the gas is expanding, so it gets bigger, and then it just pops the balloon and expands in every direction in space. But we're told that if we made a big enough balloon, when we lift it up there, it would just all of a sudden say, now, hold on, now I don't want to expand anymore. Now I want to come into myself. It's just such a stupid story.
It's got electrolytes, right? It's like arguing with the people from Idiocracy.
Yes.
That plants crave. It's that same circular nonsense.
You're right, it is, exactly.
Yeah.
It must be that way.
So I'm just gonna, I'm not sure I saved, I want the max, don't extract the ROI, extract the maximum area, so we get the second moon in it as well. And press save again, overwrite it, close, it's named 2023-11. So let me go to my desktop, and it should be this one. I will open it with this program. Free program, by the way. I actually like it even more than Photoshop. I own Photoshop. I bought it when I was younger, and I like this one more. But anyway. It's completely free. People should have this. So I just want to unsharpen mask a little bit and change this right there.
Oops, what happened over here?
Maybe there. So only spending just a little bit of time. So I wasn't very careful with the wavelets. So I do see it being a little bit. Some things are a little bit burned out, but this is the image we just were watching, and this is how you get a stacked image. There is no, when we say we use Photoshop and other programs, we don't change anything. We just stack them together and then add a couple of things like reduce some noise. And now if I zoom in right here, we get Jupiter. We could do a much better job. The captures were superb, but I didn't spend any time on the wavelets, but because I know we're running out of time. Mm-hmm. And we get the moons on the right and our Jupiter in the middle.
Have you ever seen the shadow of the moons appear on there like they show? Have you yourself seen that? Oh, it does happen.
Oh yeah. And I was the previous capture I did. I should have the results somewhere here. I was trying to make an animation. I'm not sure where they are because I have many directories and it will take me a little bit of time.
Okay.
It's going to be confusing. But yes, my job, my favorite thing to do is to create animations and show the small planet passing in front, and it has a shadow. And this is what tells me that I should be able to see the asteroid belt. So there is one other thing.
I'll show one image too. I was just looking at Cassini images just real quick, and I've showed this one before. This is a picture supposedly of Saturn. Here's the rings from the side. Here's these little things. But we already know that there is no straight lines in nature, right? Yet if you take and I'll show you, I'll take this and we'll look at this. This is a perfectly straight line. So there is no straight lines in nature unless you're talking about the rings of Saturn, which are gravitationally pulled little ice rocks. That is when we can get straight lines. This line is completely, perfectly straight across the image. We're supposed to believe that. Okay, go ahead. Sorry.
That's okay. A quick touch on the Hubble. So right now, we said that the telescope is blind and it knows where the objects are. Somebody has programmed
yes,
the whole Stellarium program inside my telescope. And then he sold it to me and I bought it. All right, so this guy was here on the Earth and he knew where the objects are, and we can go back and forth in time and we can predict where they will be or where they were. But this happens on the Earth. We put a telescope up there in the sky that is moving with the speed of a bullet, 17,000 miles per hour. That's the speed of the Hubble. So if right now my telescope is aligned, and you saw that we can take a picture of Jupiter because it follows the planet. But if I pick up one leg of my telescope and I raise it and I put it on, take it a little bit to the right, the alignment is completely ruined. So the alignment happens on spot. How did they go on the spot up there to program the telescope to know where the planets will be when it's outside of the Earth? Did they program it from down here and then they said we're gonna position it exactly there so they know where the objects are in addition to where the Hubble will be? Because that's a stretch, man. I mean, that's smart. That's oof.
Well, they're way smart. I mean, we know that.
And there's another thing that is a big problem, which is the long exposure, which we didn't have the time to do it now, and maybe we'll do it later. In order to get a distance of a galaxy, so far we've been dealing with short exposures. Let me see if while I'm talking we can see the Pleiades, which maybe are hidden by the sun, by the moon right now. It's exactly there. It's exactly at the Pleiades, so we shouldn't be able to. But my telescope cannot take good pictures of distant objects, of deep sky objects, because I have it only on an alt-az. I'm not sure what the first is, but azimuth is the second one. It's a fork. My telescope is on a fork. So in order to track an object that is very, very far in the distance, it corrects itself on the X and the Y axis together. So it makes some corrections all the time, correction all the time. So that is very bad for taking long exposures, because a long exposure means that the object must be completely still for 30 seconds. So if my telescope is correcting again, I don't get a clear image. I get a very blurry crosses and stuff like that. So in order to fix that, you change the mount of the telescope to an equatorial mount. And this is where the many money come in. And if you look up telescopes online, you will see them that they are sideways. When they are sideways and they are on the equatorial mount, this means that they only have to correct on the x-axis. So when that happens, you can take a full 1 minute long exposure of the deep sky And it appears because the objects are not moving. It is completely still. Still as S-T-I-L-L, not S-T-E. EEL, okay? Still, they're not moving at all. So your telescope is actually pinned on the object that you want to take a picture of. And after you pin it there, you can have the exposure all the way to 1 minute. And for 1 minute, if you walk around the telescope, you are ruining your picture. You're supposed to stay still, and so you don't move it. And if for one picture, for 1 minute, the shutter of the camera remains open and then it closes, then you get a very still image of the object. So if I explain this accurately for you to understand, I want you to tell me how that is possible on an object that is moving 17,000 miles per hour and giving us these great pictures of the deep sky. It is moving. It is not stable.
Yeah, impossible.
Thank you, brother. I mean,
I did a lot of time lapsing, and you just bump the camera while that shutter is open, and you're going to see a huge distortion. It's going to make a big squiggly line, or, I mean, just the teeniest time when you're shooting something that far away, the teeniest, tiniest jolt of the camera, and it ruins the whole picture.
If somebody else wants to look up the speed of the Hubble, in case I am wrong, but I think it's 17,000 miles per hour.
Yeah, it'd be right around there.
I mean, come on, man.
Taking
long
pictures.
Exposure.
And they just went up and fixed it too, and never had a problem. Just go send people there and fix it.
Yeah,
Very cool.
it had the wrong lens, they say.
Yeah, they had to put glasses on it. That's really what they did. That's what they say. Oh, great.
I mean, it's Mickey Mouse. That's what it is. The whole thing is Mickey Mouse.
Yeah, it's all put together with just, I mean, and this is the thing. People are always like, oh, the Earth can't be flat. And this, you can say whatever you want. But what we know is that we're being lied to on a mass level. And a lot of people say, well, couldn't it be another shape besides flat? Sure, but I'm just going based off of what we measure. And then also the fact of why would they teach us flat Earth was the dumbest thing in the world? Why would they teach it? Because anybody who's done any research into this, unless you're one of these staunch globe defenders where you pretend, Rufy said the other day to me, I said, we don't expect you to ever show your anomalies on your videos. You're just going to show the stuff that lines up to the globe. And he said, did you ever think, Jeran, that there's not any observations that don't match up to the globe? I'm like, I'm not talking to you. I'm not talking to you again. It's the dumbest thing I've ever heard. No, every observation ever made lines up for the globe. You're right, dude. No, not the case.
If anyone looks into any observation and anything, they will realize that at some point they are saying, we have the equipment, you don't, so you got to trust us. Right. They're not, it's not on the title, but it's always there. Like we've proved it today with the parallax. This should be enough for people to start questioning the other things that they haven't looked into. Because we didn't use any pre-belief. We just put the math down, and it just doesn't make any sense.
I agree. Well, thank you for doing that. I really appreciate it, and hopefully we can get you back again for some more stuff. But let's go around and everybody say your goodbyes. We'll start with you there. Achilles, tell people where they can find you if they want to see more of your work.
My channel is Achilles7 on YouTube. I am dedicated on exposing the lie, but not only on the shape. So you're not going to see shape stuff all the time. But there is always something in my videos about it, because I actually realized that what they are doing is a sun worshipping religion, and they make us worship the sun without realizing it. We are heliosexuals, and I keep finding things that they make ritualistic sense to them, and people don't notice. And I'll give you an example. Shakira's appearance on the MTV Awards. She was dancing with knives in her hands, and there was the sun behind her. If you go on And then the war started down in the Holy Lands right after that. If you go to a recent video, which is called Eurovision Mayonnaise, the reason I called it that is because it happened in May, and May has some significance. You're going to see that all of the Eurovision songs had the sun on the background. All of them. Why? I mean, okay, can I get a Uranus? Can I get a Neptune? If you are so into astronomy, why the sun all the time? Because they are laughing at us for being heliosexuals. So you can find me there. Thank you, guys. I always enjoy your company, and I watch your videos, even if I'm not on them. I hope
Thank you.
I hope I managed to contribute something today. And see you soon.
Appreciate it. All right. Zach, what do you have coming up?
We took last Thursday off for the GLOBEBUSTERS Tech because of Thanksgiving, but we will be back this Thursday, 7 p.m. Eastern. Not sure what the topic is going to be, but we will be there for sure. And then you can always find me over at Iron Rail Media. We had an awesome show with the YouTube channel No Longer on the Ball. He doesn't do a whole lot on YouTube, but he has created the first flat Earth wiki that I've seen.
Oh yeah, he's awesome.
Yeah, it's really cool. It's coming along, and
anybody can add to it too.
Yeah,
I love him, by the way. Shout out to No Longer on the Ball. I love him. He's a sub and very funny. Always good comments.
Yeah. Oh yeah. Great sense of humor. Just a good guy. And
yep.
Anybody can go in and add stuff. If you have any questions, you can go to the Flat Earth Wiki. Now, I know he's in Telegram. If you go to his YouTube channel, No Longer on the Ball, it will, the only information he has up there is a Telegram. And I think he does most of his stuff through there. But yeah, great channel. And really neat. The Flat Earth Wiki's coming along. You just need some more people to start adding to it. It's hard to, add all the information one person. But he's got like all of us in there. Your channel's in there, Achilles.
Oh, good. Yeah. I didn't even know. I'll go. I remember he sent me a link at the time, but it was far from being ready. Mm-hmm. And yeah, I forgot doing other things.
Oh, yeah. Yeah, it still has a long way to go, but it's coming along nicely. But yeah, if we can get some more people over there and some people adding some of their own stuff, it would help out a lot.
Okay, and Eva, what you got coming up?
Well, I'm still trying to recap all the things that we talked today. It was a great show. Thank you so much for sharing this type of conversation. I think we need time to time to address this type of technical stuff. I have a lot of things in my hard drive related with optics and things like that. So maybe another day we can share a few information. I am not a specialist. Of course, I don't have a telescope. I just have a Nikon P1000. I like to play with that type of things, but I am more. I'm a guy more from for the computers playground. I like to make renders and things like that. But a nice, really nice show and really nice topic. And beyond that, I keep working. I updating my webpage and my YouTube channel, Rockfin. Thank you so much for the support in my social networks, especially in the English ones. And we are going to have another event on 21 of January here on Barcelona. So we keep growing the Spanish community and we keep doing conference. I think we need it.
Barcelona.
Yeah, you are near, man. You are near. I think you don't understand Spanish, right? Or you no. That's sad news.
They're close. Our languages are pretty close compared to others.
Yes, completely. But we keep moving, man. I keep moving and trying to spread the word and waiting for the summit.
You are someone I could meet with because we are close compared to the others.
Yes, I I travel a lot. Not a lot, but I am living when I'm here in Europe. I'm living between Barcelona and Switzerland. So whatever you want, you chat. You have my. I'm gonna type my email and we can be in contact.
Okay, my brother. Thank you everyone for the great night. I'm actually freezing now.
Get inside, get next
too,
to the
man.
fire. All right, thank you very much, guys. And for me, we've got the debate coming up in about 45 or a half hour. So we're going to be heading out, and
I'm gonna be there watching you, Jeran.
oh yeah, it was exciting. I love people just fighting me, saying, "Quiet down, stop, don't talk over him, stop it, knock it off, don't talk over him." It's like I'm babysitting children. But
How's Brenda doing?
oh, geez, speaking of, oh boy. All right, and that's it for me, I believe. Just please check out the tickets for the summit. Support all those great presenters. Support Eru. Support myself. Support Austin and everyone involved. So hopefully you guys are going to be there.
Yeah.
What?
Read out the super chats. I know we definitely had
please.
some over
Yeah.
on Rockfin.
Well, I'll check the
We'll get-
Rockfin. Let me actually look up YouTube first because I even forgot to leave. I always forget to do that. Let me look here. We're going to go to fan funding. All right, we got commercial sound and video. Thank you very much for the 5 gifted memberships. Very kind of you. And Elaine Michael, thank you very much again for a great support, great supporter of my channel and GLOBEBUSTERS. $50 from Elaine. Thank you very much. Very kind of you. Let's go check out the Rockfin, if I can find it. Where did I put it? Okay, not there. Too many windows open here. There it is. All right, and oh, we got huge tips. Thank you very much. Let's go to tips over there. We got from Time Months. Thank you very much. $100. Thank you. Made
Whoa!
awesome.
Thank you, brother.
And we've got Heaven.
Thank you for the team.
Yeah, he listened to you. It was because you told him to. You said to support the channel, and he did. Kevin Hoyser, $10. Thank you very much. Flat Earth Eric says, great show. Thank you. We've got Flat Earth Eric talking about the airships South Beyond. He says, join us on Telegram, t.me/airships South Beyond. There's a bunch of guys there getting together talking about possibly going south. And then we've got Hubble's Whores, who says, thank you so much for my favorite Sunday program. $5 from him. Thank you all so much for supporting the channel. Please become members at Rockfin. It's $15 a month, but you get everybody there, every video there. So whether it's Big Bear, or whether it's Eddie Bravo, or whether it's Eru or myself or GLOBEBUSTERS, you name it, Austin, all of our stuff is at Rockfin, where we can get away with free speech still. So, all right. Any final words from anybody?
A shout out to Bill. I'm just checking the chat. Bill Will. Cheers, brother, and all the rest. But this one specifically because we've been talking a lot, and he's a great guy. Yeah, I think I'm done. Nothing to add. Oh, Jeran, yes, one question. First off, what was the video that you discussed that was taken down? Was it the one about carbon dating?
Which video is taken down?
You said on the previous GLOBEBUSTERS that there was a video taken down from your channel, and I don't know which one it was, but you could still find it on Rockfin.
Oh, yeah. So it was the, I'd have to go check my channel again. Let me think. Which video did they pull? There was some sort of copyright. And I think it was just my Friday show the week before last.
I think that was the carbon dating one, and I enjoyed it so much. Like it's carbon dating is such a joke.
Yeah, it's really bad, especially when I found out that they don't even date bones anymore. I'm like, what? I mean, I thought they were at least pretending to send them through some machines. Like, no, we just check the rocks, which we all laugh. They can think they can date rocks, so they're dating rocks and then saying we found this bone in these rocks, so therefore the bone is that old. It's just insane. It doesn't work that way.
And if you go to a museum, they have the bones,
No.
and they say on the sign that the bones are measured by the rocks. Then when you move further down, you find the geologic column, and it says we know the dates due to the bones that we found in it.
Right,
And that's
they don't mention
bit of a circular reasoning.
And they don't They don't even talk about the fact that there's trees that they've found going up through the geologic column. So through millions of years, this tree, which a tree on Earth can last at most a couple thousand years, is going up through millions of years of layers. And we just believe it, guys. Believe it. I'm telling you right now. If you don't believe it, you're not going to be considered smart. All right, guys, it's been fun. Thank you so much. This has been GLOBEBUSTERS. Remind you to please be kind to each other. Don't lie. And open your mind. There is truth inside. Till next time, this has been Jeranism. We'll see you in 30 minutes on my channel. Peace.
Bye, guys.